Hello YouTubers. Today we want to look at this simple power meter which I've just constructed using all in-house uh, components, as well as it's very cheap and has a nice good efficiency rate. If you look at the project, it will not have any outstanding product like finishes because this is completely done DIY. It's completely done home. So today we'll be talking in detail about what is this power meter and how does this work. So now let's quickly go through the functions of this power meter. This is a battery operated power meter. It is based on an ESP8266 chip, which gives me the capability to stream the values with whatever I am looking at live onto another device which has a web interface. So this can actually act as a server and push up values to the client who has opened the web page. The second feature and the most important feature of this power meter is measuring power. So how you do that? You basically switch this on. Since this is a battery powered thing, it just needs a 9-volt cell, which is right now sitting inside here, and once you kind of flick the switch, it comes to life. The connections is very simple. Yeah, this side is the input, the right side is the output. So if you want to connect anything to the to check the power consumption of, basically you can connect the source at the left hand side and the driver or the driven part to the right hand side, according to the polarities mapped. And as you can see, the current screen basically shows you three things. One is the voltage that has been kind of applied to this. Since now there is no enough voltage here, whatever you are seeing here is basically the noise or the junk values that are there. So it's showing around about 0.8 volts, which is nothing but the internal noise that it has. The rest part, then the second part is nothing but the milliamps that it is consuming, and the third, or it is kind of milliamps going through the whole thing. That is also currently noise, versus the last part is nothing but the wattage or the watts, that are the power that is kind of drawn from the left hand side circuit to the right hand side circuit. So currently you can see that it is very the noise basically is very low. So it's around about 0 point 0 watts, which is very low because you can see this is in milliamps already. So this might be around about this is very low for right now, I mean from the noise perspective. Overall, it is built on ESP8266 chip, as I told you, and it's based on an sensor which is basically INA219. This sensor is nothing but a voltage voltage and a current sensor on the high side. So that is how I've been wiring this up. So now, the features, from features point of view, this you have three different screens. You have an IR receiver inside, which you can see here. That basically kind of gets the signals from a normal remote, and changes between the modes that it has. So the first mode is this, where you kind of see all of the things, all the three measurements. The second mode is basically the voltage only mode, where you just see the voltage. Let me just zoom in. I think that will be much clearer. Yeah. The second one is just the voltage mode, and then previous to that, next to that is current measurement mode, which is nothing but just shows you the amount of current that has been kind of consumed, and nothing else. Apart from this, it also shows you the power mode basically. So in the power mode, you see only the power side of it. So these are the three different modes that I've kind of configured to this. Now this being completely hacker friendly, you can basically go ahead and kind of put in your own firmware and put in your own screens and stuff like that, but the basic hardware remains the same. So it's basically connected to a INA219 sensor with an ESP8266 chip. Now let me just zoom back. Yeah. So those are the features of this meter, and now let's test it and see how the whole thing works. So I need a power source for this, so let me just bring in my power source. I'm going to pause this for a moment. So this is my setup. As you can see, I have connected the meters. I have connected to the input side of the meter to this power source that I've kind of built. This is again a DIY home grown thing. So there are two power lines, obviously positive and negative, which are connected to the positive and the negative side of the power meter. Now if you now this is another functionality of the power meter, right? So even if you don't connect any load at the right hand side, it is okay, because then the power meter is just going to measure the voltage that is coming across, and the milliamps will be kind of zero. So this also becomes a kind of a voltmeter, but then it is again limited to 30 volts only. It won't go any further than that. So let me just quickly set my power. Yeah, let me set my power source. So I'm setting it to 12 volts, and I'm setting it to, let's say, 2 amps, right? And let me switch this off. So as soon as I switch on, oh, so that the thing here is also controlled via a remote control. So basically I can configure any voltage that I want and switch that on. So currently I'm trying to switch this on. So I just switched on my power supply, and now you can see that it is at 12.28 volts, and it's showing no current. It's 1 milliamp of current. That is why the wattage is also on the power source saying that it's 0.01 watts, and it's a non-stage. Similarly, you can look at the power meter. Power meter is also telling me that it is at 12 volts, 12.29 volts, which is almost equivalent of what it is showing on the power side as well. So this is so that's how basically it works as a voltage meter or voltmeter. So now I will quickly jump into the power meter part of it by connecting a load. So first I'll switch off this power source. So now it's 0, and bring in the load. Now the load in this case would just be a light bulb, something like this, and I've kind of clipped it to different to the alligator clips, and those clips I'm going to connect at or basically I'll be connecting at the load side. So here you go, plus and minus. It doesn't really matter which side you connect, because this is just going to be a tungsten like a light bulb, so there are no polarities like an LED or anything like that. So here you can see this is how I've connected the whole thing. That's my lamp. So once I kind of switch it on, the lamp starts to glow, and as you can see, the lamp is basically on, and it is registering a voltage right now on the power meter. So if I just zoom in on the power meter part of it, oops, too much of zoom. I don't know if you are able to see, but it is saying right now it's 500 milliamperes. It is drawing at 10 volts, because the voltage has now come down to 10 volts because of the current drop. And this voltage is actually across the load, so you know that what exact voltage your load is kind of getting. At the same time, you can see that it's showing around about 6 watts or 6.15, 6.16, around about 6 watts, and that is exactly what that bulb is rated at. It's 5 watt. It's an automobile cabin light bulb, so which is rated at 5 watts. So this is exactly what the maximum thing it can draw. So that's the simple explanation of the power meter. Now this power meter is, since it is battery portable and it's very cheap, you can have multiple of these connected and look at the efficiency of your buck or boost circuits, and measure across. So this is just a simple demonstration of what this meter can do. Obviously, since the internals are completely hackable, the whole software is nothing more than the let me just remove this off. Yeah, it's nothing more than basically an ESP8266 software. So all that is there is basically an ESP running inside with a web server and some battery connected to it. The biggest thing about the battery powered thing is this guy just draws only 70 milliamps at 3.3 volts. So this is it'll last quite a bit long when compared to compared to other powered things, because it's just taking 3.70 milliamps at 3.3 volts, which is almost negligible for the battery. And when you switch it off, obviously the whole thing sleeps, so 90% of your battery is conserved there. So that's pretty much it, and that is how the whole the whole thing works. I can quickly add in to show you the PCB that I made for this. Let me just pause and get that PCB for you. Okay, so here's the PCB that I designed for this. It's a very simple PCB. You have your ESP8266 chip resting here, whereas you have your INA board which is kind of sitting here, and you have a breakout pins for the OLED display here. You can actually fix the OLED display on the PCB itself, but I got a different OLED which has this point swapped, so the ground and the VCC is kind of they didn't match to the footprint that I got for that PCB. So this PCB is very simple. It's very small in size, as you can see, just I think 2 by 5 centimeter max. I think I've not measured it currently, but that's where it stands. These are the breakout pins to program the ESP. So you can see on the back side of it, basically I've kind of created a slot so that all the pins are coming out. There are 4 in total pins that are there, so you can program that on the go, or you can program it via an OTA or something like that. The rest are the inputs and the outputs. So here you can see the input connector and the output connector, and that is where basically this is where they are mounted, the studs part of it. The power circuitry is completely external to this PCB. I'll share the schematics of the PCB as well as the PCB thing. I did that in EasyEDA, and it's very simple. You kind of get it done very quickly. So that's all that I have for this video. Thanks guys. If you liked it, to share and subscribe. Thanks for watching. Bye.